received his BE in electronics from NAD University, and then he got his MS in electrical and computer engineering from King Fahd University of Petroleum and Minerals in Dhahran. And then he has a PhD in electrical and computer engineering from the University of Detroit, Michigan. He has vast teaching experience in computer engineering. Currently, Dr. Misbahuddin is professor in Department of Software Development and Data Science at Seneca College of Arts and Applied Technology, Toronto. So I would request Dr. Syed Misbahuddin to come and present your paper, and I would request the audience for an applause because Dr. Misbahuddin has actually traveled from Toronto, especially for this paper, so we must appreciate his presence. Thank you very much, sir.
Thank you very much for my introduction. First of all, I would like to recite this verse of the Holy Quran, which is the motivation of this work. And whoever saves one, it is as if he had saved mankind entirely. That's Surah Al-Ma'idah. So basically, Allah subhanahu wa ta'ala has emphasized the importance of the human being's life. So in this presentation, I would like to go along first of all, I would like to emphasize about what is the advantage of transferring the vital signs data. First of all, I would like to emphasize that why we need to transfer the vital signs data. You can see that how we can take the advantage of the transferring of their vital signs data. And then we will see that how the IoT, which is a new paradigm, is useful for transferring the data, how we can manipulate these IoT solutions to transfer the data. Secondly, lastly, I would like to present this system which we developed, and we also have developed and tested prototyping as a proof of concept. What is the advantage? As you know that in any kind of a disastrous situation, there are several patients are taken to the hospitals. In that situation, we know that the infrastructure has been demolished, and also due to all of the uncontrolled situation, the patients are trapped in the ambulances. So some of the patients could not survive before they reach to the hospitals. So in this case, if we could come up with a solution for transferring their patients' vital signs, the vital signs means that their body temperature, their blood pressure, their heartbeat could be, that information could be transmitted to the hospital in real time, then in that case the possibility of saving the patient's life can be increased. And lastly, another important advantage of transferring the real-time data is that the ER department or the emergency staff will be well prepared, and they would know that what kind of situation has occurred, what kind of disaster has occurred, so that they could be well prepared and they could be well equipped to receive the patient and to help them out to save their life. And another important thing is that the patients, the doctors can advise to paramedics to save the life, what they can do to save the what could be the necessary steps the paramedics take to save the life. And also this solution is giving us a inculcation of the AI solution to save the life of the patient. So this is the this is the architecture. As you can see here, we have an ambulance, and the ambulance is carrying several patients, and then to each patient we can have a kind of a system that can acquire the patient's vital sign, and that vital sign can be transmitted through the cellular network, which is the most prevalent network everywhere. All of us can agree, and that information is transmitted to the hospital server, and we must have at the client side we need a communication software, so we use the TCP/IP protocol to transfer the data from the patient side to the remote hospital, and at the hospital end, and we developed a prototype for our implementation. At the hospital side, we also require a TCP/IP software to receive the data, and then also we make a MySQL database to maintain the recorded information, and also we need a database for maintaining the on-duty doctors, so that we can transfer that information to the doctor's cell phone, and then so this is the board. As we can see that it can read all of the physiological data like blood oxygenation level, temperature, and all other important vital signs can be read. It's just we use this one. Otherwise, this idea, if somebody wants to extend, they can use any other smart board. That's not a that's the open solution available there. So this is our client-side algorithm. In the client side, we read we collect the patient information, then we connect to the TCP server port, and you know that in the client side targets the server. The server has a TCP/IP port on which it receives the information, and then our client side, once it has a TCP/IP connection established, then it sends the collected patient's data to the server. So this is our total, and then at the client and the server end, the server receives all patients' data coming from the ambulances through the TCP port, and then it displays the received data, and then it forwards the received data to the on-site, on-duty doctor. So this is our total architecture. So this is the detail of the prototyping for the proof of concept. So the idea that Python script is to read the received information, and then in this case our server will maintain all of the received data, and then it will make a log of the received data, and then that information of the patient's information will be pushed to the on-site doctor. So we made a MySQL database to maintain which doctor is available on duty, and then what is the IP address of the cell phone of the doctor. So in that case, the hospital server becomes a client for the doctor. So we did what? We developed an Android app for the doctor's cell phone, and then at the doctor's cell phone there is a server code running which is receiving the data from the hospital server. So this way we have, as you can see in this case in our architecture, that that the received information is displayed on the doctor. So doctor may not necessarily be there, but he would know. And this idea could be extended so that the doctor can send advice to the paramedics or to the staff to save the life of the person. So this is our contribution, and in our research the conclusion is that we have investigated a solution which can because you know that in very remote areas, for example, we cannot have an approach that doctors may not be available, and this whole solution has a potential of extending this support. We can get a support from anywhere. Maybe like for in a very remote area something happened, and then because the cellular network is also there, then we can also receive the information from the other end. And so we can save the lives of the people. And also another important thing is that we can come up with a protocol. That protocol will include all of the types of the disaster, and along with that we can make a complete package in which one field can be the type of the disaster, like it could be a food poisoning, building collapse, flood, whatever. And then we can also include complete package for multiple patients information, like we can make a one package of multiple patients' data. We can also provide the patient's information, like what is the age of the patient, if he has a pre-existing disease or not, and then what are the vital signs we are studying. So we can make a complete package, and we did that in our prototyping, and then this whole package, the whole package can contain information on the multiple patients. So we can have the doctors at the ER side will know the information for the several patients at the same time. So they can also advise. So this way we can save the life of the patient, and then we have taken the advantage of the IoT for transferring the independent. This system can be, of course, has a potential to incorporate the AI solutions, like even if the doctors are not involved, that we can have also the AI solution to improve the system. So thank you very much for your attention.
Thank you very much, Dr. Isra. We will take the question.